Hello, and welcome to Troubleshooting Application Health and Performance with PCF Metrics 1.2. My name is Pieter Humphrey. I work at Pivotal, and I'm joined by Alan Duet, who will introduce himself. Alan?
Hi, thanks, Peter. Yes, I'm the Director of Product Management here for the PCF Metrics products, and so we're pretty excited to talk today a little bit about what these products are doing and where we're going with this area within Pivotal Cloud Foundry.
Fantastic, Alan. Thanks a lot. So we'll get started just by talking about why we're here, I think, and the reason for PCF Metrics. At the highest level, I think if you look at most of the outages, mission-critical IT service outages, especially the ones you read in the news, a lot of them really result from people and process errors. Gartner's research finding, again, more than about 50% of those outages are coming from a lack of coordination. And you go out and read the news and look at some of the high-profile outages out there, and you'll find that that's true. And a lot of it is because the infrastructure is constantly changing, right? Companies are really more so than at any point in the last 10 years. Right now, companies are really looking at how they build, deploy, and run their applications from stem to stern, because it's really quite different than it's been for the past decade. From an architecture perspective, monolithic apps are certainly an option, but there's, with the emergence of all microservice architecture as an alternative, you've got a pretty big change there. Methodologies, you're seeing a lot of adoption of things like Agile and developers doing more typical operations tasks and taking the responsibility for operating their applications much more than in years past with older technology, and automating software delivery with continuous integration and continuous delivery pipelines. Just in general, features like were planned months in advance, right? Tightly coupled in the monolithic architecture, very intricate roadmap dependencies across your application, components, and the development process was very linear. You did a lot of upfront design, and that led to a very long construction phase, which is still appropriate for some applications or certain types of systems, no doubt. But a lot of people adopting Agile, especially for front end design, and then this application was deployed onto some sort of a physical machine or an infrastructure abstraction like a virtual machine, keeping in mind all your different application dependencies and the various configurations for each of those. And then once an application was deployed, ops teams were sort of expected then, you sort of threw the application over the transom to the ops team, and they were expected to manage, to deploy that app and manage the system by, maybe adding on additional services for things like metrics or monitoring and orchestration. And there was a definite sort of designated time window, right, in which your application was deployed or updated, as it frequently involved restarting the entire server. So it was done carefully, right? And you might even say that the whole culture didn't really encourage that much, because the price of failure of deployment was pretty high. As you see, in major headlines and things like the Wall Street Journal going out, stuff like that, and it's just the rate of change here. These new platforms enable such a faster rate of change vis-a-vis the last decade of technology, that it ends up it can drive more outages, actually, on the speed, and especially, trying to increase the rate of change without adopting new technology can definitely drive a lot more outages. And we've seen that in the news, right? You look at things like New York Stock Exchange, United Airlines, Wall Street Journal, out for 1 to 4 hours, right? And a lot of the causes for these things: software update, routing failures, server overload, Ultra DNS was configuration errors, Facebook was configuration and network failures, Apple App Store, internal DNS error. So some of these things are preventable, right, with automation. Now, software update is software update. If you ship bad software, there's no tool can really save you from that, right? If you're introducing a breaking application change, that's a different process to control that, and that's a quality control and a testing process often. But in terms of what platforms can offer you in preventing these types of errors and the automation that they remove a lot of these manual steps and automatically configure DNS for you and provision routes for you and things like that. And externalizing configuration from applications really could prevent a lot of these sorts of high-profile outages that are, again, very easy to find on the internet with just a little bit of research. You hear about them all the time in the news. Availability isn't the only thing, though. And I think, as you'll see when Alan shows you the demonstration, the speed also matters, right? If you look at a bit of Gartner research again, as they were talking to folks like Google, Amazon, and Walmart, and you see sentiments like this of hey, people expect a web page to load in less than 2 seconds, right? Customers would prefer another website if it's 250 milliseconds faster, and that sounds like a high bar, and it is. It is important, but it's not just that the service is on; it's that it also has to work quickly, right? So, what does that mean for us? That means looking at performance and availability is important, not just availability. And why? Why does it matter? Well, just if you look at how humans perceive things, great presentation from a Google engineer on breaking the 1,000 millisecond mobile barrier a while back. Fantastic deck. And in that deck, he talks about, basically 1,000 milliseconds is sort of that attention threshold, right? You get much past that, and you're doing a mental the user is likely doing a mental context switch, or starting to think, oh, what else could I be doing, right, while the machine is working, right? And when you get about under 250 milliseconds, it really feels, instant, like it's just immediately responded to you, right? And you can see how as the time and the latency increases, the user is sort of progressively less interested. So at a minimum, under 1,000 milliseconds is sort of that user experience design, sort of time budget that ideally you want to design for, and that's a high bar. That's difficult.
Yeah. And Peter,
go ahead. Sorry.
That can be particularly challenging when you're running microservices. If, for example, that web page is basically a composition of dozens or even hundreds of microservices, the responses on those particular microservices then have to aggregate up into that point where you are delivering those pieces faster than the 250 millisecond overlay on top of the actual delivery of the content of the rest of that page. So it can be a little bit challenging even to, when you're pushing applications that are microservices, to understand that context and to be able to drill down into that from a performance perspective.
That's an excellent point. You're right, because it could be, with the monolithic app, it's just the one binary, and you can do things like resource pipelining and other techniques. But yeah, right, exactly. How do you deal with it when there's a potential multitude of services that all have to add up, right, to equal under 1,000 milliseconds, or hopefully less. And I think there's some interesting things that your team is cooking to help folks with that, right, Alan? Well,
absolutely, yeah. Part of the broader challenge here is that, if you've got, let's say, 24 microservices that feed an experience, every one of them might look like they're running perfectly fine on an individual basis, but at aggregate, you might be delivering a plus 1,000 millisecond experience to users. So we're kind of trying to focus tools on both. How do you get that one microservice running fast, as well as what's the overall solution, and what are you delivering from that perspective? So yeah, we're trying to make sure that we keep both of those targets in mind.
Yeah, introducing distributed computing at the app level definitely does make things more complicated, but the benefits are pretty obvious for a lot of I think our listeners. But yeah, exactly to your point, right? A change to a single microservice, or of course a monolithic code base, it totally can impact the performance of the downstream services, or worse yet, break something, right? To your point. And troubleshooting this stuff is hard. A lot of the sort of modern cloud platforms, and even sometimes the older last generation of application server technology, often has a variety of different permission schemes on different applications, and that can make it really hard for developers and operators to actually get access to things consistently over a portfolio of different services. in Alan's example, maybe looking at a number of different microservices that logically compose one app, right? Having a complex permission schemes there are actually going to make things difficult. And then if you have different subsystems inside your cloud platform, you might end up with silos of different data where you have logs and you have system events and things coming from different subsystems. Also, it can be quite difficult to reconcile this sort of time series data because usually when something happens and goes wrong, whether it's a slowdown or an actual crash or an error of some sort, it's going to show up probably on more than one radar. There's going to be something in the log and there'll be a system event, for example. So there's often a need to kind of correlate data based on that point in time. And we'll see a little bit more about that in a few minutes. So what does Cloud Foundry can do for you? How can Cloud Foundry kind of address this? If you look at the sort of spectrum of all the things Cloud Foundry can do, what we're really focusing on here in this conversation is things like the capability for health metrics patching, right? These are the things that contribute towards not only application uptime, but application performance, and then helping you, the developer / operator, figure out very quickly in sort of first order of first responder, like what happened and where in the system. But before we go into the details of how that works, I think it's important just for folks to understand what Pivotal Cloud Foundry does to keep apps up by itself, right, without intervention or without any sort of additional effort. Any application actually gets several layers of self-healing. The whole system essentially was designed with the assumption that a complex system will develop some sort of inconsistency over time, right? Cloud Foundry is intelligent enough that it doesn't need to be told what to do at every step, but it's just sort of told what the desired state of it should be. And then it does the right things to make that be true. So, for example, if you say you always want 4 application instances, Cloud Foundry will make sure that statement is always true. If 2 crash, it brings 2 back, kind of thing. And there's a constant checks, balances, and detection and remediation built into the platform so that the state always returns to consistency, and that can really sort of have a big impact on the sort of mean time to resolve things and keep that MTTR as low as possible. In terms of the 4 levels, if you have an application instance, right, that fails, Cloud Foundry is going to restart it in a new Linux container. If a process fails, PCF is going to restart the failed cluster components, and it basically self-heals, right? And if there's a problem detected in the virtual machine, PCF will kill that virtual machine and spin up a new one of an identical type. Lastly, it can also be set up to distribute instances automatically across an availability zone. And if an entire availability zone is lost, the application instances could keep running. So it's with an integrated system like what you can experience with Cloud Foundry, it's multiple layers of availability just right out of the box, and no developer coding, no need to do anything there. The container scheduler can handle an insane amount of traffic. We've recently benchmarked it at up to 250,000 containers in a single installation of Pivotal Cloud Foundry in a single environment. I saw a tweet a month or 2 ago about Twitter's Mesos numbers, and it looks like they had running around 250,000 containers as well. So if you see that, if Twitter is running that level and PCF is running that level, you're probably, most enterprises are well within that range, right? And obviously, this predates Docker. Cloud Foundry has been working on container management since nearly 2011, and has been working on it since it shipped its first public release in 2013. In fact, we just upgraded the environment to use the OCI's runc container runtime. And that's a new upgrade that is also kind of helping us achieve those performance numbers and some increased security. But the nice thing about why the container management is relevant is because it really helps with dynamic load balancing for the application. So the platform itself distributes new work as it arrives and uses a very sophisticated process of bidding and auctioning workloads to balance the app processes balance the application containers across all the VMs. And like I said, that auction determines which process should get allocated to which VM and optimizes it for availability and resilience. And that's, again, there's really nothing a developer needs to do to take advantage of this. This is just sort of intrinsic to the system itself. And then, of course, if things crash, the platform is monitoring these applications, and they get restarted and then rebalanced across the available capacity. So it'll revive the VMs, and again, no human intervention is required. Great. The other thing about a really tightly integrated system like Pivotal Cloud Foundry, where we're not, unlike some other competitors or other technologies, we're not taking a dependency on Kubernetes and Docker whole hog, for example, like with something like OpenShift, where there's Pivotal Cloud Foundry sort of is designed, from one a series of the community and a lot of Pivotal committers from end to end. To be pretty consistent. So we don't need to take on these third-party dependencies and introduce seams inside the system. And that allows us to do things like this, where you can upgrade each layer with no downtime. So applications can be updated in app runtimes, things like a Tomcat or a Jetty or Resin, if you're in the Java world, can be upgraded using blue-green deploy techniques. And then from sort of, further on down the stack from the application, at the bottom of the container and all the way out to the actual sort of Linux host and kernel, you can do a canary-style deployment for upgrading. And again, this is sort of done with no downtime. The build packs that we provide with the platform are sort of constantly updated by Pivotal with the latest security fixes. And the relationship with Canonical Ubuntu Linux is really fantastic. They do an amazing job at turning around CVEs. And then applying a patch or upgrading a build pack is done by the operator with a single command. Changes, can then be applied to an app instance at the next CF push, and you can transition with, blue-green. And like I said, with operating system patches and upgrades, with the rolling canary deploys, they're sort of done in flight across batches of virtual machines until the update has permeated the whole system. So pretty incredible sort of levels of automation there. And those are all things that really do contribute to uptime. Security patching, these, obviously software update, of course, really does contribute to uptime. So with that kind of context in mind, I think, let's talk now specifically around, what is the charter for the metrics team and how can they help? And very simply, let's give those DevOps and application developers data with which to quickly assess the overall application performance and health. What broke, where did it go wrong, and help me get there very quickly. So how what kind of benefits does it offer people is that it's immediate. You get a very near real-time view. You're almost tracking reality. You're just a little bit of a delay there. And between some of the basic metrics that it offers, you're going to be able to figure out 80 to 90% of the problems and sort of locate them. Like I said, where is it, what broke, and where, very quickly, and get to that as fast as possible, so you can use the right tools to remediate the issue. The nice thing also is the integration. It's one pane of glass for the user that's correlating all the events, the logs, all the metrics. And it gives the developers and the operations kind of a shared set of facts to use, which is nice. The tool is certainly available to sort of either audience. And obviously, since this is a Cloud Foundry, a tile, this has been designed from the start for Pivotal Cloud Foundry's multi-tenant architecture. And there's no installation. It's just automatically enabled for all applications. There's no agent that sits inside, streaming, being network chatty and streaming things out. It just works. So what kind of data does it emit? Obviously, we're going to get Cloud Foundry system level events, but we're able to correlate those with data coming from the application itself, the metrics, and the log files, as well as things like routes. And this will probably only increase over time as we explore more and better ways to generate data, because with data there's possibilities and there's more interesting future automation possibilities with the more data that we generate. So it's pretty simple. So I think Alan's going to show you a little bit about how it works. We're just going to select an app and then start to watch the streaming data and figure out how to interpret it. So let's take a peek. And Alan, why don't you tell us a little bit about sort of what's in this release, and then let's see it in action.
Yeah, sure. Thanks, Peter. That was great. Good setup. I'll try to hit all of those points, blue greens and scale events and everything. We'll show you what they look like in the tooling. We really focused over the last, since the 1.1 release over the last few months, on getting PCF Metrics 1.2 kind of set up based on some feedback from our customers here. In our previous version 1.1, we had application logs and metrics both displayed together, and we stored that information for about 24 hours and for just high-level aggregate data. And so one of the things that we've been looking at in order to get to that more like, hey, how do we cover that 80 to 90% of cases scenario is getting more data. And in fact, what we were looking at, I'll show a couple of examples where we would talk to customers and say, well, this thing happened on Friday, but we were in firefighting mode. And so by the time we got back around to trying to review this on Monday to figure out what was root cause, we really actually, that data wasn't around anymore. But we really wanted to kind of take a look at, see what happened post the event, kind of after we were kind of out of the woods. Beyond that, obviously, there's a lot of power to seeing what trending is happening over periods of time and having a broader context. So something might have changed a few days ago that is now kind of impacting. And so for all of those reasons, what we did was we really increased the storage of the information size here. And going from 24 hours to 2 weeks is actually, interestingly, more than 14x the effort than one would expect. So we kind of went underneath the covers there, did a fair amount of re-architecture pieces there in order to both get to a fault-tolerant stage where we're storing that data in a way where if it's all highly available, the data itself, both for ingestion and for storage and reliability reasons, and then making this work on really large loads. So Pivotal Web Services happens to be one of those examples of a fairly large deployment of a multi-tenant version of Pivotal Cloud Foundry, and we've been making sure that we're more than adequate to use that load. In fact, we've been testing out on up to about 3x the volume of currently of Pivotal Web Services, which runs closer to about 2,000 app instances. 16,000 app instances at any given point in time. So it gets you information on that if you're interested. But we're really kind of making sure that we can ingest and store that data very reliably. And in fact, what you'll see there is not only do we get the data, we get that data out in some kind of clever ways. We're able to show you, for example, a histogram of the logs and across that distribution, obviously able to correlate that information back and forth across things like application events. I'd love to just jump in right now and show the application itself. So what you're looking at here is our PCF Metrics 1.2.1. This is actually the one that's in Pivotal Web Services right now. And it is for an application that I have posted from my account called CF Presentation. That's my Oregon space there. I'm looking at 2 days worth of data, and what I'm looking at is both the events that have occurred in that system over this time. So within Cloud Foundry, the Cloud Controller will tell us if an application has exited, if a container has exited via crash, an update maybe to the container itself, if there's a stop and a start to the container. The actual container metrics, so CPU, memory, and disk utilization, these are aggregates across all the instances of the containers, but we actually do store all of the individual instance pieces. And then the network requests, so all the HTTP start stops across this particular application. This application happens to have multiple routes, so it'll take both routes. I say both routes, it'll take all the routes, and then we'll bring those particular pieces up. So it'll give you the traffic information and the numbers of those that are errors. So for us, errors are things other than 202. So they might be things like a 500 response on the header. We also look at that network latency, and we're specifically looking at the latency between the Go router, the application, and the exit request for that from an HTTP perspective. That's really helpful in understanding what your particular performance is like for any given request. This is an aggregate because you're getting hopefully lots of traffic across. But again, we are individually storing that information behind the scenes so we can give you kind of granular stuff in the future if that's what people are interested in. We line up the logs, and here's that histogram we were talking about here. When do these things happen? What's sort of the inherent sort of frequency level of that particular piece? Line them up, and then any given point on any of those pieces will then reform that information right to that. So if I wanted to look at right at the peak of maybe a request spike, down here in the logs area, I'm going to be lined up right at that point in time. Interestingly, of course, here's the logs. You can kind of get a feel for at least where we're at right now. With this is all the different traffic. So there's the presentation. We'll have other traffic coming into the other routes, et cetera. You can kind of get a feel for who's sending that maybe, or what kind of routes people are selecting to take into and through your application. We have a pretty robust filter and highlighting system, but probably what's more interesting is to say, don't show me any of that router traffic. Just show me sort of maybe something like, well, where was things like the API, so the cloud controller, the cell itself, if it's sending out any logs or any health statistics. So the cell will send out things like, hey, we're getting ready to create that container. We've created it. We're starting that new container. And it will obviously just show you where the latest information was. So this is rolling back. And as I'm rolling back through time looking at these logs, I'm actually moving that needle so that if you need to pinpoint something, we say, ooh, wait, what was that exit status 0 here? As I roll back up, I can at least get that context about what was happening at that point in time. And I can tell that something, an update was happening to my app right at that point in time. Now I can have a couple of selections here. I'm looking at 2 days worth of data, but I can just highlight and select any given range of data and then align right up on that. And I'm still keeping that alignment on that last piece here. Let me make sure I get on that exit status of 0. And what that's going to show me here is how that lines up to the event that I've got marked here. What is that event? It was an update. I can tell from context, just looking at my application here, that what I'm seeing is that over the last, let's see, since about 8:50 this morning, my application got some traffic here, some network requests. And there's a bunch of these updates. And I can see the updates are more or less clustered around some of these spikes in that traffic. Now, I happen to have the autoscale portion of PCF Metrics running. And this is actually, I'm cheating a little bit because in PCF or in Pivotal Web Services, they're running the feature set that is going to be available in PCF Metrics 1.9 here, where I have the ability to create scaling rules on both HTTP latency and throughput. And sure enough, I can see that if my throughput is over 2 per second, then I'm going to increase the number of instances I have up to, let's see, what was that? From minimum of 2 to maximum of 5 to try and service that traffic. And if I line up on one of these pieces here and scroll on down, I can see, sure enough, I can see what is happening. I'm changing my instance counts to 3. I'm changing it to 2. It's downscaling at that point. It makes sense because when I look at it, I'm on the downward portion of that network request spike. And as we move forward, I can kind of just basically tell what some of the automation was happening. Now, Pieter mentioned in some of the slides how we do blue-green deploys. And even those blue-green deploys kind of end up showing up here for me so that as a developer or as a DevOps resource or even as an operator, looking at this particular app to see, hey, what's happening here? Am I having a problem? Give me some context about what's recently happened and then give me some idea about what performance load has happened on the system both historically and recently. I can tell from looking at this cluster here, and I can of course go in the logs as well to see that what we really did here was we probably moved from, let's say, 2 app instances to 4 app instances as part of a blue-green deploy. We rerouted traffic to the 2 new ones, and then we shut down the old 2 application instances. And so I know I did a deploy. What time was that today? That was about 12:30. Sure enough, that's right. I did a blue-green. I did an update to my application. I blue-green deployed, and as part of that blue-green deploy, actually got a little bit more efficient in terms of its use of memory throughout. So I can see both the context of what happened, and I can see the ending results of that from a performance load perspective. And of course, later on, I got some more traffic, and I went through that auto scale was continuing to work for me. It went ahead and took care of how many instances of the application I needed at any given point in time. That's interesting because as you're looking through the system, there's quite a bit of logs, and not just from these pieces. Obviously, the application emits logs. You can get that traffic, that routing traffic log that we saw before. Trying to find the root cause or the piece of information that's particularly useful might feel a little bit like a needle in a haystack. Now, we do give a whole range of different helping pieces here. For example, I can look at keywords, and I'll go ahead and I'll filter by instances. We saw those earlier, but I want to be able to basically see all of those events. Sure enough, here's my instances up and down. I'm just going to filter in that particular case. I might want to just highlight something that's available within that that output, like I know I see updated here somewhere, and it's going to go ahead and select those particular pieces out. And so we're giving you some tools here. This is actually behind the scenes. You'll see that we're implementing Elasticsearch, so you have a fair amount of information there available to you. But from a classics perspective, we're actually able to just come in here and let's say, I know I'll get some people hit me with Postman. Let's see what that looks like within this result set, and you can look at the distribution now of that. And you can see that not all the traffic during these spikes are actually coming from that, but a decent amount of my traffic is actually generated straight from there. As I line up, I can find one of those pieces. They'll obviously be highlighted through the result sets. So this is just kind of a generic example, but if you have any type of output from your application with keywords or special things, obviously crashed is a pretty popular one. If you want to see, for example, when did that thing happen? This is the best way to do it. And then, of course, when you have that, then you can come back and correlate that to information that was made available for you up here. I don't want to kind of understate the fact that, like, when you look at these, one of the key things that I think a lot of app devs, both from a troubleshooting and performance perspective, look at is sort of what is the performance load that's put onto the applications at any given point in time. So as I mentioned before, this is running multiple instances of my application, and the container information here is actually an aggregate across all of the instances at that point in time. So even though we went from 2 to 4 to 2, we were smart enough to know that, hey, I didn't actually double the amount of my memory and simply not reroute it. I put 2 more instances up in the blue version of the deploy and then rerouted traffic. So we don't actually show you this like big memory availability spike or this big reduction here. We show you sort of the true usage based on the routing, which ones are live and picking up traffic and what are they doing. Now we do, of course, behind the scenes we can collect specific metrics on a specific instance, but oftentimes it's not about the specific instance. They'll spike up and down. What you're really looking for is you're looking for load across events like this, where you come in and you say, I had a bunch of traffic and I increased my instances. Did I actually did I get crazy in terms of my utilization? Well, my memory went up a little bit here, but it recovered pretty well. I look pretty good. I'm actually probably over allocated in terms of my resources deployed in this on this particular application. So these are kind of the things that we look at. Obviously, network latency is also kind of a big thing here. We do network latency by looking at the HTTP start stops, and that's a very good indicator more of what's your performance like for your application. So if your application is kind of grinding on something, that'll be there. We go ahead and count everything here and show it to you. and other parts of the system, like when we're doing auto scale. Just jump here just to give you a little bit of a differentiation. In some cases, you'll see people do something like this where they say, hey, I want to eliminate like the worst 1% of the traffic so I can get a better feel for average latency look. We feel like when we're representing this information here, if there are outliers that skew the data, we'd still like to actually show you that information, even the skewed information, so you can go in and dive in and figure out, hey, maybe there was only 2 of these things that were open for 5 minutes, but they were open for 5 minutes, so that was a bad experience. Let's go and see what that what the root cause for that was.
You need to see the outliers as well as all the data. So, Alan, one thing I'm just curious about, this really seems to form the basis for the auto scaling, right? This is what I meant earlier when I said with data becomes there are possibilities, and what you're showing me here with the auto scaling is really intriguing in that the more data that we kind of surface, the more interesting potentially the auto scaling can get in the future. And
yeah, absolutely.
The other thing I didn't really, the other thing I didn't really quite realize actually until you just showed it to me was that you can use this tool to help right size containers a little bit and not over allocate resources, right? That's an interesting. I never thought of that until you just showed it to me.
Yeah, absolutely. And in fact, I think one of the things that's kind of scary sometimes when you look at that line is not knowing kind of what the historical graph is. So that's you kind of gave me the perfect segue there, Peter, around saying, hey, let's look at this thing and let's look at all 2 weeks of data. We actually we do our best attempt to visually show you what's happened over that 2 weeks of information. It can kind of look flatlining in some cases. And in fact, you're seeing one of our use cases that we specifically kind of call out here where we got into a scenario where we wanted to show what a platform outage, like if everything possibly went wrong, what would that look like to an app dev? So if they came in and somebody said, hey, your app's not up, and they brought up this tool and they were looking at this on November November 18th at 9:06, what were they seeing? They were seeing this big gap in Intel. And so behind the scenes, we're looking at more and more ways that we can kind of represent information coming from other parts of the system like autoscale and then help affect those pieces. In this case, this would be sort of something along the lines of, hey, Logregator was down. We happen to own Logregator here as well in Denver, so we're kind of familiar with how to break some of those behind the scenes pieces. And we went ahead and did that for a handful of these apps so we can show like what would this look like, and then how could we better represent that information to customers using the same view. So like you said, that platform operator could come in and say, well, sure enough, it's not your app because you're not getting any of this stuff, and I would at least expect to see that you were getting some information pushed through or some crash event happening here. Instead, what I'm seeing is that I'm missing some Dopplers, or I'm missing some information coming out of a different part of the Cloud Foundry deployment. And so we're able to actually kind of bring some of the more and more of those pieces together. Looking over something over a 2-week period here is a much safer indication to say, well, am I over allocated or am I under allocated in this case, versus just saying let's look at it over a couple of hours worth of time, or even a day or two worth of time. The classic example is that you'll get spikes usually in midweek and probably level off towards the end of a week. And so looking at some the information set for a couple of weeks at a time, well, you can give you a better feel for saying you're right. I probably could save some RAM by changing my my memory limit for this particular app, and then go to town with that.
Now, one thing, Alan, one thing real quick, just because I can already hear the question from the audience, right, about, well, how do I save the data off in perpetuity so that I can analyze a year's worth of data? I know that's something we're thinking about, but not yet supported in the product. Is that true?
Yeah, that's true. In 121, yeah, no, that's a very fair question. We do get that. In 121, we had to kind of look at a little bit of a compromise here between 24 hours and multi-year storage, because that's really the range of kind of feedback we've received in the past about how long we keep data for. We really feel like, at least for an operational perspective for DevOps, as you kind of mentioned, 80-90% of the cases, of looking at a problem or trying to make some changes to the system, or at least trying to find context so you can eliminate your particular application as a potential portion of a solution problem. Really kind of come down to we can do that with 2 weeks worth of data. We do have some plans here in the future around storing more data, or probably more likely what this is to say before we go through what we call a pruning exercise where we eliminate the information after 2 weeks, allowing you to store it off so that you would be able to kind of reconstitute a much, much larger data set. So things coming on that front, but you're right in saying, at least for right now, we store it
an
2
archive,
weeks.
exactly, like
Yeah.
be able to shelve it out. Yeah. That's cool. Okay, I just know we get asked that question so often, so I figured we'd take it on the nose right now.
Every day. Thank you very much for that. So every day. So yeah,
no problem.
Absolutely. For us, this is really kind of the big picture view of where we're at right now. Being able to give you this context, being able to give sort of some rich functionality around diving into the applications themselves, trying to find specific pieces of information, as well as kind of to try to triangulate based on information that you see through here, and doing this for an individual application. Of course, that's where we're currently at. We feel like that's a very useful tool for an individual application. I'm going to jump back to the presentation for just a moment, and just point out, like, hey, that's where we're at with this particular slide. The next slide here we have go straight to
I mean, what you're showing is very helpful for monolithic architecture, and PCF is very well known as a microservice platform as well, right? So. Yeah, absolutely.
So behind the scenes, I'm going to show the architecture diagram kind of quickly, and then show some of the other things that we've been playing around with here a little bit. We are basically pulling stuff from Elastic Runtime's Firehose. So this is the log aggregator system. We consume interestingly, these ingester and these log queue are actually CF applications that run. We pull the out, and then we store logs into Elasticsearch. So we run a pretty decent-sized Elasticsearch cluster for you behind the scenes. You can obviously, the operators configure sort of some of the information on sizing for that. We do store this data in MySQL partly because some of this information is event information. Obviously, time series data related to container metrics and HTTP start-stop traffic as well. And then we aggregate a lot of that stuff for you before we then make it available. Basically, everything below this line is how we represent that UI for you, up to and including making sure that users who have access to this information can get it, and users that can't. I'll show you one quick thing here that's kind of an important piece. When we look at information that is part of like a log, for example, and of course I'm going to spell that wrong, there's going to be potentially pieces of information that are redacted. And I'm sorry, I'm actually not in. Let me go ahead.
I was just about to say you're not screen sharing, so yeah, there you go.
Well, good. You didn't get to see my awful spelling. Okay, so in this particular case, what I did was I went ahead and I just typed in private data. So what we're seeing in this kind of situation is where we're smart enough behind the scenes to say, hey, as a user, you have access to this particular log, no problem, but you shouldn't be getting this environment JSON feedback. So we don't kill the log for you, but we do redact information out of the log that your security system basically says, hey, that's not right for you. And so similar things there. If you don't have space authority here, we're not going to let you have access to this. In fact, I'm through the drop down here, I can see all of the apps that I do have access to see this through, but none of the apps that I didn't grant permission to. So I'm not a space developer on a few apps, and so I don't actually have an app to kind of go into that. And so we honor both the perspective of saying, hey, I'm Alan Duet, I'm Duet Pivotal.io and PDEP, so I can give you a multi-tenant solution for this, but also individually, even if you're not in that, if there's information that you shouldn't have access through your UAA stuff, we're not gonna bring you there. last little piece here is I wanted just to do a little bit of setup in terms of how we're moving forward. Pieter, just to your point exactly, like this is the more interesting piece, I think, when you're in the microservice layer, is that we're bringing in support for traces. And my apologies, I'm going a little bit off of some wireframes here, but this is very, very similar to what we've got built outside of the ugly pink and purple and green, better colors kind of there. But we're adding in where we can detect in logs that trace output is available in that log. We'll let you hit what we call a Trace Explorer. That will actually bring that trace ID for that particular log and find all the other logs with that trace ID. We'll go so far as to try and give you the span in terms of timing and the hierarchy in terms of calls. So, you know, in the classic example of Spring Sleuth, that's a great solution for doing these types of traces and sampling. And we'll actually bring that into PCF Metrics. Let you take a look at those particular pieces and a whole range of, as you can imagine, as you're clicking into any one of those pieces, then kind of filtering back down into finding the appropriate logs and calls and you name it there. The idea here is that if you're in a microservice environment, then, you know, one service calling another service or one major service calling multiple services and their routing requests and whatnot actually add up to that piece. So knowing that you know, in this case, this particular call is taking the longer part of the overall experience helps you kind of drill into, well, what was the thing there? We see tons of different use cases around, you know, when a change happens over here on foo, then what does that mean to doodad? And if doodad is now acting inappropriately, the app dev for doodad may not have made any changes. So then the previous kind of set of scenarios where they're looking through to see what things have altered or changed that affect their outcome. Now that might not necessarily be visible. In this case, you'd be able to hopefully clearly see now that there was a delta here, and then get right to the logs that tell you why it's you know, why it's behaving differently now than it was. Probably the foo guy forgot and isn't passing something important on to doodad, and doodad is then having to go look some information up. So, you know, the classics here around trying to make sure that that microservice, that Uber architecture and that Uber experience is being delivered consistently, even though individually these apps probably have different life cycles and different changes happening to them at any given point in time. We're working on this right now. We actually have this fairly far along, and so we're expecting to have this in our 1.3 version of PCF Metrics, along with a handful of other things. I'm going to jump back to the presentation real quickly here.
And just while you're doing that, Alan, I think for any of our listeners that are not familiar with Spring Cloud or Spring Cloud Sleuth, you know, just as a bit of context, what Alan was showing us is just something in the Java world. The Spring framework is an app development stack that many people use, particularly for microservice architecture, and that Spring Cloud Sleuth project. It just is an ability. It's a nice bit of integration there with, you know, with being able to deploy Spring Cloud microservices and then being able to correlate response times across a complex network of them. A nice little bit of PCF integration there with Spring. So just for anyone unfamiliar with those concepts. So sorry, Alan. Yeah, you were going to talk a little bit more about where it's going.
Yeah, sure. So this is kind of our broad journey. We started off trying to just get metrics out, and we're at the point now where getting metrics and logs, and we're pretty robust and fairly confident in terms of our data storage, and we're really moving on to these additional features like that, microservice and trace ID capture. I know we'll get the question of will we be able to do trace ID for anything beyond Sleuth. We really are targeting Sleuth as our integration partner, as Pieter pointed out, all the behind the scenes. We capture the information in a way that if any log information is kind of formatted in a similar function, it'll automatically work for you, but we're able to expand upon different trace ID captures and representation in the future as well. Obviously, it helps when you have a good partner like Sleuth in the mix there, because it gives us a specific implementation target. We're doing that right now. So we're hoping for some very good feedback on that. We're looking forward to it. Some of the other features that we're looking for there is that Spring Boot actuator support. This is where you basically can send metrics from your application that are custom app metrics. So they don't have to be container specific. They can be application centric. Expanding on that so that basically any apps can send metrics back into our system, although our visualization of just generic metrics might be a bit challenging. We'll have some constraints there likely in terms of formatting and what information is available, but we will capture that for you and make it available. The event descriptions, as you saw, there was a lot of updates and start-stops. We actually know now in the newest version of the Cloud Controller, CAPI, or our Cloud Controller API, actually sends more discrete event information to us, and so we are taking that and we're making that available now in these pieces. So like a restage event versus a new versus an update, a whole range of different CAPI information pieces will become available through our UI about those events, and then the additional log sources. I don't want to lead you into believing that we're letting anybody send any logs. What we're really saying here is that there are different parts of the system that will send logs that we are ignoring right now that might be useful. Typically, there are things like lower level logger style services behind the scenes, but it might be informationally relevant for folks. And so we're bringing more and more stuff that's available through our logger gear subsystem into the system. We'll expose all this data as an API. That way, if you don't like our UI, you can go create your own or do analysis on it as you see fit. And then we've got a whole bunch of user experience improvements that we're targeting for the future and looking forward to getting into 1.3. We love feedback, so by all means, if you're using 1.2.1 or you have ideas about 1.3 or beyond, please let us know. We're constantly working in this area. So an important part for us as a Cloud Foundry implementation partner, or a component, I should say, but also in Pivotal Cloud Foundry, the metrics piece in particular has been received very well, and we're hoping to get more and more folks involved with helping us drive this roadmap forward. Pieter, that's kind of what I have for now.
Actually, I just want to also expand a little bit on the Spring Boot actuator support, because again, I don't want to assume that all of our listeners are, who are likely PCF developers or operators, necessarily know Spring as well. But the Spring Boot actuator support is really quite interesting. It's that's basically the modern Spring essentially is Spring Boot. And for any Spring Boot application, actuator endpoints can do a number of interesting things, including custom health information, simplest from simple to complex, dumping out environment information, what Spring beans are in the application, metrics even. So, and I believe there's the ability to do, I think it's either custom metrics or custom health. But the interesting thing is that there's just deeper and deeper look at supporting Spring applications and integrating them into the rest of the platform. And Spring Boot is becoming quite popular, not only on Cloud Foundry, but just in the industry in general. So the actuator support is, just going to be yet another reason why Pivotal Web Services and Pivotal Cloud Foundry are just going to be the best place to run Spring that you're going to be able to find in the market. And we're working hard to continue to expand that truth and deepen that truth. And this is just sort of yet another way. So the actuator support and the trace and correlation IDs for microservices, I think, are going to be two very important pieces of that. So Alan, I know the Spring team and a lot of other Spring developers are very interested in this work for that reason. And if you want to try this, I think actually, if you wouldn't mind going back to your screen share for a second, Alan, this would be really cool if you can. If you can't, don't worry about it. But it'd be cool just to show the Pivotal Web Services dashboard, the app manager, and just show that for almost any app that you put in there, all you need to do is click on that little link right there, View in PCF Metrics. There's literally nothing that you have to do if you're running this on Pivotal Web Services. It is available for you by default. There's no install, there's no nothing. It just works, which is fantastic. So, no setup time, no friction. And if you want to go try this, it's as easy as setting up an account on Pivotal Web Services. I think it's $87 of free trial credit when you sign up for an account, and you just need an email and cell phone to do the two-factor authentication. Currently, PCF Metrics is not available on PCF Dev, which is the sort of local workstation version of PCF. So it's it's better to try it on the public cloud for now. And very very quick and easy way to get started. So Alan, let's see what kind of questions we've got, and wrap. And then once we're done with that, we'll wrap it up and call it a day. Great. So I think our first question is from Kieran at Schwab, Alan, and he was asking if there's an alerting mechanism as part of PCF Metrics.
Yeah, so it's a great question. We actually have built an alerting mechanism. It's not available in the release right now. We actually had some of those components in a previous release and kind of went back to update some of the ways that alerting is done. So there are some nuances there around saying, hey, we want to give you information as soon as it's relevant versus waiting and marshaling it for a while. So in this particular release, it isn't, although alerting in PCF Metrics, particularly what we call application alerting, so you can basically set some threshold, like if my memory is more than 90% for 5 minutes, shoot me an email or send something to Slack. That's certainly on our radar, and we've been working on alerting as a capability with this type of technology for a while. And so it's coming. It's not in the current 1.2.1 release, but we'll get it out fairly shortly.
Cool. And Alan, Kyle from CSAA Insurance had a question that I think kind of goes back to what I was saying earlier about in the webinar about with data, there's possibilities, right? And one of those possibilities may be auto-scaling with other things. His question is, are there plans to expose logs and metrics from the data services layer?
So I think I'm interpreting this question as, can some of our services or service tiles like Redis, MySQL, Rabbit, et cetera, send in logs and metrics, and that's absolutely the case. We're basically consuming these pieces of information right now out of the log aggregator Firehose, and up to this point, that Firehose has really not been able to kind of support metrics specifically from services up until recently. And in fact, in a recent release, some of that is available now. We call it tagged metrics. It allows a structure that will allow a service like Redis or Rabbit to then tag that metric as it's sending out on behalf of something, for example, like an application ID, so we can get good correlation on some of those pieces. So we are working with those teams to get some of that information in, and for us to understand that service structure, we definitely want to be able to do something like a trace across all of both the microservices and the service stack layer. And so, yeah, you'll start to see more and more of that flow in. The capabilities, I think, behind the scenes are now laid down in the coming version of PCF, and we're certainly capable and ready to start bringing in some of those additional pieces behind the scenes here. They're just not being emitted yet in a way that we can show them. So, yep, we've got that coming. Peter, you still there?
Oh, sorry, I was on mute. Brian from Cerner Corporation asks when the 1.2.1 tile is going to be released, and what is the release date for 1.3?
Yeah, so technically the 1.2.1 tile should be available for you right now. We have gotten some reports today that when people get to PivNet, they're still seeing the 1.5.1 tile. if that's the case for you, apologies in advance, and you should, we'll try to clear up any issues for folks who are seeing that here within the next hour or so. The tile is ready. It's been ready for a while, but it looks like we're having a little bit of a snafu with our release on PivNet, and that's going to get worked out shortly.
Great. Okay, thanks. Got it. Maybe if you're really hot to get it, maybe an alternate workaround would be to create another login or something for the time being, but maybe just wait an hour and you'll be fine. This question comes from Chris at Luxoft, and he's curious, for the Spring Cloud Sleuth on PCF Metrics, does the app need to include the Spring Cloud Sleuth libraries for having the trace ID, span ID? And I'm pretty darn sure the answer there is 100% yes, but
yeah, well, that's our official position right now, is that that new piece here, we're building it so that we understand how we can pull that trace ID out of logs. That is obviously we're just doing like an expression like a regex where we're just detecting from those logs and then pulling it in. I'll tell you, technically behind the scenes, if you happen to be emitting in the same way, that we will actually parse that log anyway and get that trace ID out and pull it into the app. So the UI doesn't really know it's a sleuth-based piece. Although right now all that we're doing is we're looking for the way that sleuth emits those span and trace IDs. We did this specifically because obviously there's a really great use case with sleuth, and we can kind of lock down and understand those cases. And rather than build something generically that didn't really work, we wanted to build something that was that we knew we could express and how it worked. And sleuth does a really good job of allowing us to kind of understand those dependency chains. Obviously, moving forward, more technologies become available, or if there's more demand from customers, we'll bring in additional support. But behind the scenes, we didn't necessarily couple it from a UX perspective. We just we're using that sleuth as the canonical kind of deployment and implementation right now, so we can get a good experience with it.
So, Alan, I'm going to just replay that a little bit, and because I think he was also asking something slightly different in the sense that I think what you're saying is that the handoff point is sort of the format of the log, and if your application includes the Spring Cloud Sleuth library and you're making use of it in your code and enabling the output, right, then it will obviously output in that format, and PCF Metrics is expecting that format, and therefore everything works swimmingly. But you're saying the exchange point is really the format at the end of the day. And so as an app developer, if you're looking for something to generate those trace IDs, span IDs in that correct format, Spring Cloud Sleuth is currently the solution. However, that doesn't, the door is open for other things in the future, right? So
yeah, absolutely. Yeah.
Does that sound right? Does that sound fair?
That's correct. Yep.
Okay, cool. All right, so I think there was one other, we got that question on the logs and metrics from data services. That's really interesting, by the way. I wasn't aware that you guys were working on that. That's really cool. Because, often connecting to external data services, that's often sometimes where problems lie, right, is when your app has a dependency in the database, or, in the modern world, right, your app has a dependency on another cloud service, which in turn is a database. So frequent, I can imagine that's going to be really popular when that comes out. One last question from Mitzvul here at Pivotal. He asks, is there any use case to detect an IaaS layer issue like a network packet drop?
That's a good question. For items like that, we have actually, here's the interesting piece. You can kind of do that one of two ways. You can do sort of a direct analysis of the information that's passed through. We don't store, for example, right now, like ELB or any type of routing, logs that are external to Cloud Foundry. So, in that case, we don't have access to that via log reader, and we don't store that, and so we don't see it. Although in general, you can kind of see a few areas when you do some anomaly detection. If you look at the HTTP start-stop traffic, where you can kind of tell that, hey, this doesn't look like it's been a completed a route all the way through from start to finish on things, or you basically will see like, hey, these four things all happen in a sequence, and look at that, this thing's kind of like stopped midway through. So from a pure data analysis perspective, we kind of looked at some of those things and said, well, there's probably some value add that we could maybe do in the future around saying maybe there was some potential loss there. But in terms of doing a direct detection of some of those pieces there. Some of that data is just kind of out of our remit, and this is actually a good place where we start to hand off some of the some of the solutioning to some of our partner solutions, because they do that particularly well, right? They both understand the context and have access to data streams from the IaaS or the infrastructure layer and routing and network layer, and now Cloud Foundry. And so we kind of look at that as sort of a bit of a nice jumping off point for some of these other complementary solutions. Not to say we won't go in that direction, but I think from our perspective, we realize it's better to do a direct detection and analysis versus trying to back your way into potential infrastructure issues by trying to do some anomaly detection from our end. So that's kind of where we've been. It's an interesting question. We certainly love to hear more if there's folks with feedback on what they'd like to see there.
So again, let me play that back to you, because I know I've heard that question a number of times from customers and other folks curious about the technology. And that, so would you characterize the kind of state of the union of sort of where partner tools pick up and where PCF Metrics sort of leaves off? Is it sort of fair to say that a lot of the third-party and partner tools tend to be more full stack, whereas PCF Metrics is going to be somewhat by definition a little bit inward-looking to the platform? Is that a fair sort of?
Yeah, that's really fair. I mean, it's a bit challenging for us to kind of move into that infrastructure space, and of course we have a lot of context and can bring a lot of domain-specific things for the platform itself. So it kind of is our natural handing off point to some extent for some of our partner solutions.
Yep.
But yeah, absolutely.
Yeah. Well, yeah, and it's a fine line, right? Because PCF definitely prides itself on being an app-centric and app-aware platform, and that's certainly a major part of what we do, right, as a company and as a open source community. Great. All right. Well, I think that attends to the questions, folks. If you're curious where you can try out PCF Metrics, if you go to the bottom of the question stack, and we talked about this in the webinar a few minutes ago. The easiest place to get started is on Pivotal Web Services. You get just a reminder, you get $87 of trial credit, so you can try it for free. And the nice thing, nothing to do, right? It's just automatically enabled. If you're curious, if you want to share the recording and/or the slides with one of your colleagues, this is being recorded, and the URLs of where things are going to get posted to is at the top of the question list there. I posted a question on, is this being recorded, and that's where the links are. If you're a PCF customer and you're looking to download metrics, like Alan and I were talking about before, the URL is off of network.pivotal.io, and again, that's in the question stack. You'll see a where can I download PCF Metrics, and then a great place to go learn more, is just the docs on PivNet. It's a great jumping off point for if you're looking to learn more and you want to actually be able to read something as opposed to watch something. So great, and I think that's it. Alan, is there anything you want to say before we kind of call it a wrap and say happy holidays to everyone and let them go about their day?
No, we just love to get feedback from folks. We have a lot of outreach, and so if you're interested in this area, please feel free to contact us. We're also have a Slack channel on Pivotal where we'd love to hear from you, the PCF Metrics channel.
Oh, that's right. Actually, thank you for reminding me. There's one other little bonus question or bonus thing. If you are a Spring Boot user, we would love to hear from you. Our design team actually would love to hear from you. I'm going to post this right now in the question. So if you're a Spring Boot and PCF or PWS user, they would definitely want to hear from you, because one of the other areas that we're working on is Spring Boot actuator integration with the app, PCF's App Manager. So let's see. So if you're interested in giving us some feedback on that, I think there might actually also be a gift card involved. So I'm just posting a link to that right now. There's a Google form, I think, for you to register to register your interest, and I'll tweet about this from Spring Central as well. So if you are Spring Boot users and you're interested in giving us some feedback and possibly winning a gift card, check it out, and at least it's your opportunity to sort of influence the direction of where we're going with continued Spring Boot and Pivotal Cloud Foundry integration. All right, well, thanks, everyone. Appreciate your time and attention. Hope to see you back on a future installment of our webinar program. Have a happy holiday.